All right, so let's take a look at number 24. So number 24 says 3 to the 1/4 power times 27 to the 1/2 power is equal to 3 to the x power. So I got 3 to the 1/4 times 3 to the third. Now, where did this come from? I'm trying to make sure I got the same base for every term. So this already has a base of 3. This has a base of 27. This got a base of 3. So I'm like, all right, well, if I can get everything to have a base of 3, I could probably work with this. So 27 is equivalent to 3 to the third power. So I convert 27 to 3 to the third power. So I got 3 to the third power to the 1/2 power. It's equal to 3 to the x. So then I got 3 to the 1/4 times 3 to the 3/2. Now, where'd that 3/2 come from? Because one of the properties of exponents, the power of a power rule, multiply the exponent outside the parentheses by the exponent inside the parentheses. 1/2 times 3 is 3/2. That's where the 3/2 comes from. So now what I can do, because I'm multiplying these together, I use another property of exponents, which is the multiplication property of exponents. 3 to the 1/4 times 3 to the 3/2. Add the exponents up. But you got to know how to add fractions. You got to know how to find a common denominator. So this is 3 to the 1/4. This is 3 to the 3/2. The common denominator is for 4 and 2 can be 4. 4 is the lowest common denominator between 4 and 2. So therefore, I need to find an equivalent fraction of 3/2 that has the denominator of 4, which would be 6/4. So 1/4 plus 6/4 is 7/4. So I got 3 to the 7/4 power. So now I got my equation where I got the same bases on both sides. I got a 3 and I got a 3. So then I create an equation with just the exponents. 7/4 is equal to x. 7/4 is equal to x. So it's no more work to do. That's it. 7/4 is equal to x. Or you could rewrite it using the property of symmetry and just say x equals 7/4. Either way, you good. All right. I hope that helps.